There are a number of security threats on a wireless network, but to summarize the main ones, these are the main areas that we are concerned as wireless security threats. First one is the rogue devices. Rogue devices can be AP or client, and it should be detected normally at controller level. So controllers are responsible to detect these devices and contain them. Controllers have the rogue AP detection algorithm, and they can easily detect the AP. So any AP that are appears in the database of access points are known as a rogue AP, and it's going to be contained. Then we have ad hoc network problems when we don't have any centralized management for the security, and the connection and security is left to the devices itself when they are authenticating with each other. The client association issues and passive or active attacks. Attacks and mitigation. We have passive attacks when a hacker is just listening to the transmitting data. It's called eavesdropping, silently capturing wireless frames, and it's usually used to form an active attack. So passive attacks, in like any other networks, this type of attacks happens like this. So passive attacks is basically collecting information to form an active attack. An active attack is when an attacker might send a flood of association requests to an access point and cause the overwhelming the access points, and basically creating a DOS attack, and make sure that the access point is no longer doing the service to the real clients. So this is type of the DOS attack, basically. Based on information gathered by controllers, a wireless intrusion prevention system can detect many types of wireless network attacks. In the IDS, so controller-based IDS can detect and contain, but wireless intrusion prevention system can detect, contain, and prevent. Usually the introduction prevention, like most of the time, we can say all the time as well, intrusion prevention systems are placed after the firewall, even the intrusion detection one. Because if you leave them before the firewall, any traffic from the internet is going to be blocked, and it's going to have lots of overhead and doesn't let anything through. Wireless client authentication methods. We know that if clients wants to connect to the access point and communicate in wireless network, it needs to be authenticated to access point. So either using Open Authentication or some type of shared key authentication. The method of authentication evolves as we had facing more security issues, security weaknesses. So as the stronger the attacker gets, we need to make sure that we introduce the more strong authentication methods. There are several authentication mechanisms or type, and they can be used together as well, so you don't need to have only one running. The first one is Open Authentication to the access point, which has no authentication process, basically not a specific one, the one that using with the username and password. Then we have Shared Key Authentication to the access point. We have EAP Authentication to the network, MAC Address Authentication to the network, combining MAC-based EAP and Open Authentication, then using CCKM for authentication clients, and WPA using WPA2 key management. The Open Authentication is the first one. It offers the open access to WLAN. The only requirement is that the client must be supporting 802.11 authentication request before it attempts. So basically, since the authentication request is supported as 802.11 standard, and the access point gives the association to connection to the client. You can see it's very insecure. So why do we need to have open authentication? Why do we need to use it at all? One reason of using this is when you want to test a client to see if it's a valid 802.11 device. So one reason is for validation of the hardware and see if it's supporting the protocol. And the other time that you use it, when they use the authentication, is done in the different level. There is another server or something else handling the authentication. So first the access point give the authentication, open authentication, give the access, but to access the resources, there are other ways to access the resources. One example is a public location WLAN. Sometimes they use the web authentication if you ever use them. If it's an open authentication, like in airport, you open the mobile phone, the wireless connection on your mobile phone, you choose the network SSID and you connect. And if you recall, you have to open a web browser, tick some terms and conditions, and then you get the free access. Sometimes if you need to pay for this network, so to use the network, so access point again gives you same procedure. You choose the SSID from the list and get access. You need to click that term and condition, and also you need to pay to get the username and password, and sometimes it's the only one-time use password. This is an example of open authentication. Most of the operating system, when you are, sorry, the picture is not that clear, but basically it's the flag that shows that this, not to notify the user that this connection is not secure, so your data might not be secured when you are using the open authentication. One way to secure the authentication is the use of wired equivalent privacy or WEP. 802.11 standard traditionally defines this method, WEP, as a method to make sure that the wireless communication is secure and is equivalent to the wired connection. WEP uses a RC4 cipher algorithm for encryption, and it's basically an encryption and authentication tool. The algorithm uses a string of bits as a key. It's known by web key. You can define 4 different web keys, but you can only use one of them. All these web keys are numbered, so when the the transmission is happening, the number of keys should be identified so the receiver and sender knows which one to use. WEP keys or web keys can be either 40 or 104 bits long, represented by a string of 10 or 26 hexadecimal digits. You can use this and practice this web key configuration in the lab 5, when you can choose define different keys and you're only using one of them. The authentication method is in the way that during the shared key authentication, access point sends an unencrypted text, which is called challenge text. It takes a string to the device that is attempting to communicate to the access point. So when the device is requesting for authentication, the access point challenges the device by sending an unencrypted text and requires to encrypt it and send it back. The device is the one that requests the authentication, encrypts the challenge text and send it back to the access point. If the challenge text is encrypted correctly, the access point allows the requesting device to authenticate, otherwise it drops it. So the device can communicate only if its WEP key match the access point's WEP key. So if the key doesn't match, the encryption doesn't match, it drops the packet and drops the connection. And devices not using WEP do not attempt to authenticate with an access point that is using WEP. So authentication request, authentication response comes back from the access point. Association request, response comes back. WEP data frame to wired network, and if the key mismatch is there, so like the key is not the same key, and it's the packet is going to be dropped. The shared key authentication to the access point, because of the security flaws that we had, it is not recommended anymore. So it's not recommended to use the WEP because the unencrypted and encrypted challenge text, it can be monitored by attackers, and with the comparison, the algorithm can be predicted easily. In 2001, a number of weaknesses were discovered and revealed, but it takes for 3 years, by 2004, that the IEEE 802.11i amendment was ratified and WEP was officially deprecated. The reason is because wireless hardware manufacturers are usually reluctant to commit to build products until the technology is firmly established in the IEEE 802.11 standards. So unless that it is not fully established, they won't do it. Therefore, the WEP was an underlying theme for a very long time. So it took so much time, but despite the fact that they knew it's not very safe. And even now, you can find that it's still available because of backward compatibilities. And in the lab, you can see you can still configure it. Basically, it took years until it was actually not used anymore. We need to find a better wireless security methods. Both open authentication and shared key authentication do not use the radius server or any authentication server. So we have to find a method that uses the server basically to handle that, to make it more secure. To overcome the problem, 802.1x EAP was introduced. The original 802.11 standard authentication method, like Open and WEP, were not secured. So the new one established an extensible authentication protocol with more flexibility and scalability was introduced as an authentication framework. EAP uses not only one but number of authentication methods, and it integrates with the IEEE 802.1x port-based access control standard. So it's not like 8.11, it's 0.1x, which is the port-based. Wireless clients might be able to associate with an EAP, but they're not able to pass any data unless they do the authentication. And a dedicated authentication server is required here, so it's not done between only access point and client. In this diagram, you can see the steps that 802.1x takes. So we have supplicant, which are basically the client device that is requesting access. We have authenticator, the network devices that provide access to the network, usually a wireless LAN controller. So in this section between the access point and the client, we can have the open authentication, but the real authentication happens from WLC onward. Then authentication server, or IS, the device that takes user or client credentials and permit or denies the network access based on what username credentials on the database is, and the policy set for that user. Usually we use the radius server for that. And the whole thing is a EAP-based authentication. So as I said, this part between the client and access point, it can be open, but when they want to access the information, access any data, transmitting any data, then the authentication is required, which is more stronger than open or WEP. EAP authentication to the network, it has a couple of steps. In the next few slides, we go through that. This authentication, the authentication based on the EAP protocol, is the highest level of security, can provide the highest level of security for our communication, wireless communication. By using this extensible authentication protocol, we have access point acting in the middle between the EAP compatible radio server and the client, and make sure that they are performing the mutual authentication. And to do that, they are using a dynamic unicast web key. So this web key is created on the radio server, not on the access point, like when the previous example of the web key we looked at. The radio server sends the web key to the access point. AP uses the key for all unicast data signals that the server sends to or receives from the client, and the access point also encrypts its broadcast web key, so it makes it more secure, can't be tampered if people are eavesdropping and capturing the information. With the client unicast key in it as well, so when it wants to broadcast it, when you want to encrypt it, it encrypts the broadcast web key plus the unicast key and a client's unicast key and send it to the client. It's easy to understand through the diagram. From step 1 to 9, we're basically going to show how the device and the radio server on the wired LAN uses 802.1 X and EAP to perform the mutual authentication. So this is the whole process. So the radio server sends an authentication challenge to the client. So first of all, the client starts communicating with the access point, authentication request to the access point, and access point responds to make sure that this is a client that we want to connect. So before going any further, access point does a bit of a communication here. Then the client uses one-way encryption of the user's supplied password to generate. So before that, the radio server sends an authentication challenge to the client. And this is basically, if you're looking at this picture, this is when it receives the username. So first, radio server needs to receive some information from the client to make sure that, okay, I have this username, so let's send an authentication challenge. When the client receives that authentication challenge, which basically it's a radio server sends to the access point, and access points relay that to the client. The client uses a one-way encryption of the user-supplied password to generate a response to the challenge and send the response to the radio server. So basically sends a response that yes, I can do that, and then authentication successful comes back, that's the password it sends, and then the challenge, the server is still waiting for that challenge, the web key that it created first, to be sent back to make sure that it's a legitimate client and give the authentication to it. So basically finish the authentication process. Using information from user database, the radio server creates its own response, basically that's for the challenge one, to make sure that it is a correct response. When the radio server authenticates the client, the process repeats in reverse. So basically, and the client authenticates the radio server. So both need to be authenticate each other. Basically, that's what happened. So it's quite secure if you compare it to the previous version when we talk about the open authentication or web authentication, which just happened between the access point and the client. When the mutual authentication is completed, radio server and client both agree on a web key that is unique to the client and that provides a client with the appropriate level, which is this wired switch that segment to the individual desktop, so same level as that. The client loads this key and prepares to use it for the logon session. During the logon session, the radio server encrypts and sends a web key called a session key over the wired LAN to the access point. Remember, access point is working in the middle here, transferring the information between the radio server and the client. The access point encrypts the broadcast key with the session key and sends the encrypted broadcast key to the client, which uses the session key to decrypt it. So basically, client already have the session key and use that to decrypt this. The client and access point activate WAP or web and use the session and broadcast web keys for all communication during the remainder of the session. So that way it makes it secure. When the key was generated first by the radio server and agreed with the client, and now access point has it as well. There is more than one type of EAP authentication, but the access point behaves exactly the same, basically sitting in the middle, relaying the authentication messages between the client and the radio server.